Hello, everyone. Good morning and welcome to our session. We are sorry for the delay that appeared here. Um, Unfortunately, we were waiting for the chair, but we can start here by the first paper. We are looking for the first paper entitled "Generative Methods for Planning Public Transportation Systems." Uh, could you please let me know who will present the first article? I think Alexander Morozov is
Yes,
currently
yes, it's me, morning.
Good morning. Are you ready?
Yes, I'm
Uh,
ready.
you can share your presentation.
Just 1 second, please. Um, so do you see the screen?
Yeah, of course. Is it full screen, right?
Yes, it's full screen.
Very nice. And you can start. Thank you very much.
Okay. So morning, everyone. My name is Alexander Morozov. I'm first year PhD student at Institute of Design and Urban Studies at ITMO University, and today I present work generative methods for planning public transport systems. So the transport system is a crucial component of the city as it directly impacts the mobility, employment opportunities, and social inclusions of citizens. So optimizing this system is essential due to the challenges like modern challenges like population growth, urbanization, and as improved public transport can reduce environmental damages and traffic congestion. So existing optimizations methods are costly and data intensive. They require more efficient approaches. So our study aims to develop a genetic algorithm-based method to plan and optimize public transport routes, focusing on minimizing average travel time to evaluate the system's development for potential. So the optimization of a city's transport system focuses mostly on enhancing efficiency, minimizing travel time, adaptability to passengers' demand, accessibility, cost reduction, connectivity, some customer experience, and equitable distribution of services. Uh, to do these tasks, researchers do some transport models that represent the city transportation network mathematically for analysis, forecasting, and optimization. They vary in detail and computational requirements, with the macroscopic models being less accurate but efficient. Microscopic models offering high accuracy but requiring extensive data and computational power, and mesoscopic models balancing the two approaches, often used for public transport routes planning. Transportation demand modeling, essential for these transport models, involves methods like real-time traffic demand modeling and mobile data usage. So, optimizing public transport routes, it is a complex NP-hard problem that can be approximated using combinatorial optimization algorithms, including meta-heuristic approaches. So, the optimization of an urban public transport systems relies on input some parameters such as public demand, geographical characteristics, and available transport quantity. The goal is to create routes and schedules that maximize the coverage, prioritize direct trips, and minimize route lengths and number of routes. This involves processing data on the road network, potential bus stop location, and services. Um, Generative metaheuristics methods, such as genetic algorithm, now currently preferred due to the complexity of the problem. And these methods, our method generates numerous designs until predefined conditions are met, offering advantages in handling complex high-dimensional solution spaces. So, in terms of our problem, the main that is the existing public transport routes planning methods rely mostly on identifying demand locations, but do not consider time cost and transport connectivity. These indicators, in our opinion, are important because they are the main targets of current agenda of sustainable urban development, according to United Nations and other modern city planning ideas. Um, so, as I said previously, planning potential public transport routes involves complex modeling that require a lot of extensive data and computational power. We propose the method that generates new routes or modifies existing ones to assess their impact on area accessibility using open data. The metric transport connectivity, that is the mutual transport accessibility of urban areas, shows how urban areas can be related to each other in terms of travel time when they are physically close or distant from each other. This approach allows us to integrally assess the quality of transportation services through time costs and to see which parts of the city are cut off from the rest through the public transport network. All calculations were performed on a block network model of the city, which speeds up the indicators computation. This model was assembled using the BlocksNet library, Python library, represents city blocks connected by paths derived from an intermodal public transport graph. As an optimality criteria, we propose a value of average block connectivity of a city of a given area, which was obtained again with Python library BlocksNet. Bus routes were taken for optimizations. To evaluate the performance of the bus route system, we developed a fitness function that calculates the average block's connectivity by combining a modified bus route with an unchanged part of the original intermodal graph containing information about other types of transportations and unchanged bus routes. So to model, we choose the area of Vasilyevsky Island, the district of the city St. Petersburg in Russia. And to model it, we use open data from OpenStreetMap. We use the method of generating urban blocks from Python library BlocksNet. And we use an intermodal graph that represents the public transport system of the city. The edges of this graph are pedestrian ways, public transport routes, and the nodes of this graph are the points of connections between the pedestrian sections and public transport stops. So this graph contains the routes of buses, trams, trolley buses, and underground. And travel delays due to traffic congestions are not considered in this graph. Each mode of public transport in the intermodal graph along the edge without taking into account traffic jams with a fixed average travel speed time. Um, so the algorithm of our method is mostly about modification bus network. It involves optimization of routes by sequentially adding and removing direct routes between existing stops using a genetic algorithm. The method uses the street road network graph to obtain travel time information for new routes, keeping transport speeds consistent with the initial intermodal graph. If stops aren't directly connected, the extra algorithm finds the shortest travel time by identifying the nearest vertices, so node, and summing the edge of weights. So the genetic algorithm starts with initial population of route modifications, where random edges are replaced with a pairs of edges, including new stops. Each modification's fitness value is calculated, sorry, and the top of 50% are selected as parents using the two-number selection algorithm. Parents undergo crossover, then combining parts of their root list to create new individuals. Mutations involving random age removals and additions are applied with probability p, and this process repeats for a set number of iterations, producing an optimal route modification with the best fitness value. So we did some experiments with the single route optimization to test the method. We applied it to the single bus route number 220 in a given area of Vasilyevsky Island, and in different experiments, the route modifications may vary due to the stochastic nature of the genetic algorithm. These figures show the modified route. As it can be seen, the new route makes two duplications. It drives to the stop that are close to our on its route. And the connectivity shows the mutual transport accessibility of a given area. The longer the time, the worse the connectivity of one block with another one. So in the figure, it can be seen the black outline of some blocks, and this shows that connectivity values have changed approximately for 2 minutes and half a minute respectively. So we did a bus route network optimization for whole system of Vasilevsky Island, and the average travel time for this area was 23 minutes, and number of routes were 19, and the result of the method generated bus routes that optimized transport connectivity shown on the figures. The number of routes has not changed, but uh, the increase of terms of connectivity was insignificant, but it was some remote areas have become better connected to the rest, as it can be seen in this picture. Uh, Improvement in terms of average travel time was like about 1 minute to 22 minutes after optimization. The increase is insignificant, but we guess it's a good start. This approach allows us to integrally assess the quality of transport service through time costs and to see which parts of the city are cut off from rest through the public transportation network. We propose the method for route generation, and it has potential for development, but has several disadvantages, such as it is not considering important data, for example, on transportation demand, speed variations through the day, and frequencies of transfers. But at the same time, it can also be an advantage compared to modeling if such data are not available. So in the future, we are planning to develop this method to incorporate transport demand and to make route generation responsive to transportation needs. And basically, this method is intended to determine the potential of the transport system and the routes for development in non-optimized area where public transport is not existing or just developing, and where we can find unavailable data on street road network. Since transportation modeling is time consuming and expensive, this method can provide an estimate based on unavailable data. Um, I'm done. Thank you for your time. I'm ready to answer your questions.
Thank you very much for your comprehensive presentation. It was very nice. I would like to ask the participants if anyone has any question. Okay. I have a couple of questions in my mind and about your presentation. It was really thorough and comprehensive study, which was really well structured. And congratulations to you. Um, I would like to ask that for the measurement of the connectivity in your research, you adopted a very interesting method. And since there are a wide range of methods for measuring connectivity in urban network systems, I would like to ask about your adopted method to measure connectivity. That is it possible to use or convert these outcomes of data in the form of quantitative data or not?
Um, Excuse me, thank you for your question. I didn't understand the second part, but I can tell you about the transport connectivity because it's like a concept and the method to calculate this metric that we did in the previous year, and we want this metric as it is based on transport accessibility of territories. So it mostly shows how territory connects in terms of time through public transport. Uh, we did a research of the development of this metric, and we did some comparison, for example, to see how urban blocks connected with each other by, for example, Euclidean distance and the distance on a public transport system. And we saw that some territory may be, for example, close to each other, but they are separated, for example, by the natural barriers like rivers in the cities or parks, for example, and it could show us I understand that sometimes we have in cities areas that are maybe not so important to be connected with another ones, but this metric can show us integral transport accessibility of the city in the whole way. And please, could you repeat the second part of the question because I
Uh,
didn't understand.
yeah, I would like to know that is it possible to convert or transfer your obtained data to the numerical kind of data or quantitative? As a matter of fact, we have.
Oh, yeah, it's I guess it's numerical because the transport connectivity, like it shows every block of the city has its travel time. We collect, we calculate the transport accessibility um, in terms of adjacency matrix, and when we uh, see and when we do for example, every block contains a median time travel time to another one in the city.
Okay, thank you very much for your presentation and good luck.
Thank you.
Okay, um, we are going through for the next presentation entitled Enhancing Urban Planning Through Improved Connectivity, a genetic algorithm approach to optimal service placement. Uh, could you please, if anyone is the presenter of this um, article?
Uh, Hi, yeah, good morning. Yeah, I'm here.
Hi, Georgie. Good morning and
Uh,
welcome to our session. And we can start your presentation. Can you please share your screen?
yeah, sure.
Okay,
So,
we can start.
sorry, may I ask you to mute your microphone? It's a bit
Yeah.
noisy somewhere on the background. Okay, yeah, thank you. Um, just a second. Um, okay, so um, just just one moment. Okay, so I hope you can hear me. Um, ca- uh, can you see the screen actually, or you cannot?
Um, uh,
Oh, I see. I see. Okay.
please
So,
full screen. Thank you.
so okay. So
It's okay.
now you see, right? Okay. So let's start. Morning, everybody. My name is Gary Koncevic, and today um, I'll present you the results that we've gathered during our research on the enhancing urban planning through improved connectivity, genetic algorithm approach for optimal service placement. And let's start with some background for this work. So you're probably familiar or just heard about the term jobs housing mismatch. Is a kind of thing that if workers live on remote from their place of work, um, they're less likely to to perform well on a long distance. They will change their occupation like each 2 to 3 years to like something closer to their home, and long commuting, usually uncomfortable, also has a negative impact on their overall well-being and consequently on their life satisfaction and job satisfaction. Uh, so, as Alexander Morozov just presented, like before me, the improvement of connectivity in a city is a crucial thing, usually related to the public transport. And if Alexander's work was dedicated for the algorithm on like generating new routes, my work is aimed to show between which blocks we need to increase connectivity um, to make like the level of life satisfaction of workers of specified like plant, let's say, uh, like better. So let's go to the next slide. Um, yes, as I said, in this work, we have investigated the scenario uh, where we have like some area in the city, as you can see on the left side on the screen. We also decided to um, conduct our experiments on the St. Petersburg. And here in the center of the slide, you can see that we've chosen the area between like some residential blocks and the port. It is like the area that is not developed yet, but it will in like in a few years. So there could be like basically any type of facility, and what if we'll place a plant there? As you understand, um, the attractiveness of the city or specific part of the city for skilled workers might be a crucial thing in terms of like budget that the city has to like build the plant and support the infrastructure for the workers and the residents that would live near it. So based on jobs housing mismatch approach, we have selected several blocks that um, yeah, that's better. We have selected several blocks where potential workers of this plant could work. It isn't far um, from the plant, and it is also affordable to live in. So these blocks, like near the facility, were selected to further consideration. Yeah, and as you can see, we use the BlocksNet library, which allowed us um, to actually obtain the urban blocks and to get the intermodal graph of public transport in the city based on OpenStreetMap data, both for city morphology and for public transport routes. Yes, so next slide. A little context. When we speak about the level of life satisfaction and job satisfaction, it also involves not only like the um, the satisfaction of the place of occupation where people like work at, but also on the other hand, it involves the assessment of our residents like have needed services in nearby area like clinics, shops, restaurants, etc. And we can assess it. And when we assess it and understand that probably in some blocks there is an unfulfilled demand. For example, on the left part of on the slide, you can see that the green blocks are fully covered by service. Here we are considering the service of clinic, which is like crucial service, right, for life of the city. and some blocks are not fully covered. So it means that this area where we are planning to base a plant might not be very convenient for potential workers, and consequently won't be as attractive as it could be. So to solve this problem, there exists several methods of optimal service placement, where we need to find the best location for new service, which will cover most of unfulfilled demand. And on the right part of the screen, you can see an example from the PySal library, which kind of incorporates many different implementations of such methods. Yeah, and the key idea here is to place like the minimal number of additional services, since they're like costly probably, and fulfill as much demand as we could. So next slide. And we had a hypothesis that in general case, this task of adding a new service like is usually considered for restaurants, cafes, and so on, where we are not able to modify the connectivity between different parts of the area, right? But as urban planners, actually, we can, because we are in a power of suggesting new routes, probably some ad additional roads, or something, and it's kind of in our hands to a bit increase the connectivity between certain parts of the city, certain blocks. So some remote services could be reachable for some residents in different blocks, different buildings, right? And here's our hypothesis. So each service has its own accessibility normative, which was stated by the government, and for clinic it is 15 minutes. And we thought, okay, what if we will decrease the time of transiting from one block to another, from the house to service, and would that help to place less services than we would need to? And we chose the decrease level of 30%. So basically, if there are services that are in 25 minutes accessibility, we will decrease it, and actually it would be possible to fit in a time normative. Okay, so there's a method overview. Basically, it's a basic genetic algorithm. But the key thing here is a fitness function, where we put our optimization problem. So here we use CPSO. This is the method that not only places optimally the new service, but it also incorporates the capacity and the demand of residential buildings and services. So here on the slide, you can see the results that on the left side, it is the representation of how change the number of required services through the generations of the genetic algorithm. So as you can see, initially there were required 13 services, and now the number is decreased to 9. And on the right side, you can see the proposed decreases in minutes in commuting between different blocks, and from 2 minutes to sometimes 10 or something. Yes, and as you can see on the next slide, using the BlocksNet library, we have assessed the provision of the clinic service before our optimization, which was like 0.7, and after, which increased to 0.9. That's it. That's it for me. Thank you for your time. I'm happy to answer your questions if you have some.
Thank you very much for your presentation. It was very interesting and appealing. And I would like to just put a minor comment on your presentation. Although it was very nice that we have your presentation with lots of graphs, but it would be much better to provide, in some cases, captions for the figures and tables.
Mm-hmm.
It would be more understandable for the presenters and the participants. And my technical question is about, since we have not see any discussion in your results, I would like to ask about the contribution of your research. For example, I would like to know that in comparison with the other researches, other studies, published studies in this field, I would like to know that if your study has any distinguishable or any contradictory outcome and results comparing to the other researchers in this field or not? Thank you.
Okay, yeah. Thank you for the question. Um, yeah, it is. So the main idea there was that during the like solving location location problem where we need to place some new facility, new service to fulfill the demand. The problem itself is considered like having a fixed adjacency matrix, like the time of commuting from one house to a service, from one house to another service, and so on. And usually, as I said, it is considered as a constant. And here, like adding a bit more optimization, like additional optimization inside the process, um, we are not considering it as something constant. Here we like play with it, proposing some kind of new matrix, which actually could be um, incorporated with the approach of previous presenter of Alexander's. So here we are able to model the changes, like possible changes in the city, and assess like, okay, if we would like put a road there, or something else, how it would affect the residents? Would that just uh, there was an idea actually. We haven't tested it yet, but um, for example, we could solve like the unfulfilled demand problem without actually adding new facilities, but just adding new routes or new roads, probably generate new roads, like new connection, and that's it. So this is like it is a small thing actually, but it is kind of crucial to be able to understand how the city evolves and how it affects its residents.
Okay, thank you very much for your response and clarification, and good luck.
Thank you.
Okay, dear participants, we are looking for the next presentation. The next paper is entitled Automated Identification of Existing and Potential Urban Central Places based on Open Data and Public Interest. I would like to ask if anyone, if the presenter is online currently. I see Anna is online, and you are welcome to present your results.
Okay. Okay. See you the presentation.
Yeah, yeah, we can see your presentation.
Okay, let's start. Good morning, everyone. My name is Anna Pavlova, and today I'd like to tell you about. I'd like you to present you the findings of our research on a novel approach for identifying urban central places in modern cities based on open data and public interest. Yes. Let's talk about the importance of central places in cities. First of all, every city is a complex mechanism with interconnected parts. Central places are a crucial part of a city's urban fabric. Central places result from variations of in natural resources, spatial inequity, accessibility, and collocation of urban services and citizen activities. Neglecting central places can lead to issues like spontaneous migration, reduced quality of public places, limited access to services, and a blurred urban environment. Existing interpretations existing interpretations and methodological approaches to identifying central places are limited. So a new data-driven and comprehensive approach to identifying central places leverages open data, public interest, and modern technologies, defines main types of central places, existing and potential, and it aims to provide opportunities for further urban research and effective urban planning. On the slide, you can see the business process modeling diagram of the method. The new developed method consists of 6 main stages: identification of the study area boundaries and division into blocks, extraction of points of interest or POI using data engineering techniques and natural language processing, definition of transport accessibility using a city network graph and indexing each city block, identification of existing urban central places based on the distribution of services, and POI, identification of potential urban central places based on transport accessibility and public interest, and visualization of the results on a map. Central places can have different profiles. The study decided to identify the following profiles: gastronomic, including all kinds of catering establishments; trade, including large stores and shopping centers; cultural, consisting of theaters, museums, and other attractions; multi-profile central places, in which services of different profiles are represented to the same extent. Further, places that have high public interest and good transport accessibility, but absolutely no developed services of any of the profiles, are considered potential. The initial data for the method's work are the boundaries of study area and its quarters or blocks. The coordinates of urban services located in the area points of interest, and the transport accessibility of the blocks expressed in minutes. Due to the large amount of calculations at the stage of collecting and processing the initial data, it's recommended to use an area of no more than 150 kilometers. So on the first stage, we filter out blocks with poor transport accessibility. On the second stage, we count the number of mentions or POI within each block. At this stage, each block is assigned a recognition score. Blocks with no mentions are excluded from further research, as they are considered insignificant for users. Next, we divide the services into 3 profiles: gastronomic, cultural, and trade, and count the number of services within each block for each profile separately. Similarly to the previous stage, within each profile, the blocks are assigned a service concentration score, and then we compare the service concentration of different profiles to each other and identify multi-profile central places. Finally, we determine the remaining blocks with good transport accessibility and a large number of mentions as potential central places. The final maps for the Moscow district in St. Petersburg in Russia are presented on the slide. The central places of government profile are shown in blue, the trade profile in red, the cultural profile in green, the multi-profile central places in yellow, and the potential central places are shown with hatching. As it can be seen, almost all central places are concentrated on the north and the selected district. Such results can be explained with the closeness to the city's center, where all the guards are mostly placed. In conclusion, this study has demonstrated the applicability and effectiveness of the method for automatic identification of central places, confirming its significance for practical use in various areas of urban planning and development. The purposed method for automatic identification of central places based on open data and public interest is not limited to the case study of St. Petersburg, but can be easily extended and applied to cities in different countries and continents, providing a versatile and transferable approach to unravel centrality patterns in different urban contexts. The method provides valuable insights for stakeholders involved in urban development, enabling them to make informed decisions and optimize the growth and livability of cities. Further research and refinement of the method can further enhance its utility and contribute to the sustainable development of urban environments. So that's all. Thanks for your attention. Have you questions?
Okay, thank you very much for your comprehensive presentation. It was very nice, short and sweet. And I would like to ask the participants if anyone has any question from the presentation of Anna.
Mhm.
So I think it's done, and I would like to thank for your presentation. Have a good luck.
Okay.
Okay, we are going to the next presentation. Um, the next article that uh, should be presented is entitled "Forecasting Cascading Effects in Network Models as Applied to Urban Services Provision Assessment." And I would like to ask if the presenter is here. Yeah, Vasily, I think, is the presenter of this uh, article. Good morning, Vasily, and we are looking for your presentation. Could you please share your screen?
Yeah, I'm trying actually. So I hope you can see it.
Uh, at one moment, it appears for us, but right now we can see your face.
I'm sorry. I'm gonna just show the whole screen, I guess. Okay, like that. Can you see it right now?
Yeah, we can see that. But if you could full screen, no. All right, it's very nice, and we are looking for your presentation. Thank you.
Okay, good morning, good day, colleagues. My name is Vasily Starikov. I'm presenting our work on the topic of forecasting cascading effects in network models as applied to urban service provision assessment. And I'm going to start from the introduction that the ongoing projects for transforming the urban environment do not take into account the impact on the quality of the life of residents of other areas of the city in the context of the provision of urban services or amenities, as you can call it also. So there's a need for city models that can allow us to assess the effects of such transformations of the urban environment at the level of the entire urban system as a whole. So a block network city model can be used as such model for provision assessment. And the task of assessing the provision can be reduced to the problem of distributing the population between urban services of certain capacity and subsequent calculation of the ratio presented on the slide. So various approaches to the problem of finding the number of interactions are considered, including basic iterative methods, gravity models, and linear optimization methods. But in this case, gravity models may be too sensitive for the parameters of the city network model, but the use of but also the use of graph network model, the graph neural networks can be also useful and it's becoming widespread actually. So the approach to assessing provision for accessibility zones is relevant for types of services for which requirements are presented and defined by standards like schools and kindergartens. But to assess the provision of non-standardized services, we can try to assess such provision through diversity. So such assessment methods can include measures of homogeneity and or assessment of biodiversity like Shannon entropy, Simpson index, etc. So what actually is a cascade effects? In this work, we mean that cascade effects are some changes in values of the provision assessment of urban services that arise in the city as a result of the transformation of the urban environment in the local area. So you can see an example on the slide. Actually, it's also a problem that we can't define how it changed actually. So it's So we tried to develop a method, and we developed a method. The provision assessment method is presented on the slide and consists of two sub-methods. Thus, it allows us to assess provision of both in terms of standardized and non-standardized service types. So as an input, we use a block network city model from, as you've heard before, BlocksNet library. We use open source data like OpenStreetMap and other Russia related sources to fill information about buildings. So we can we try to calculate the diversity through Shannon entropy. Uh, for the Shannon entropy, and it calculates as follows. So we tried to calculate it for the life situation feeling unwell. So we have a list of services in which we actually calculate the diversity. So we tried to calculate it straightforward. And in this situation, if you calculate it for each block separately, you do not take into account the links between blocks, and um, thus no cascade effects may be observed actually. So we try to wider the area of city block assessment, but actually cascade effects limits at such threshold of 10 or 15 minutes, and we thought that if we expand the assessment zone, we can take into account all the neighbor blocks, and based on distance between them. we can assess the cascade effects of development scenario in such way, and the cascade effects decreases, as you can see on the slide, but not equally for all the blocks. So some blocks um, some blocks react to it in a more um, in a more extreme way, as you can see, for example, in these blocks. So if we add some services here, this exact block, despite of its distance, it reacts more because it was more important for him to have such services for its diversity. So in case of standardized provision assessment, we decided to use graph neural networks, and our experiments were not that successful. We used unit network architecture and random walks-based architecture, and tried to predict target of nodes that we calculated before using using linear problem solving methods like reducing the problem to transportation problem. Uh, but sometimes the results became too smooth and we couldn't just interpret the results, like what they actually mean in this way. But we can try to describe the problem of distributing such of distributing people between services as a problem of many backpacks. This problem can be solved using graph neural network, considering backpacks as services, weights as demand created by the population of the block, and cost is the travel time between demand and service blocks. So uh, as you can see on the slide, we on the slide here is a provision delta that we've obtained after calculating the current state of the Vasily Island, and when we added the population, when we increased the population of such of just one city block, and we got the decrease in provision of schools for not only surrounding city blocks, but also city blocks that were like far away, actually. So the approach exhibits several advantages, including the ability to operate independently of a teacher, the flexibility to configure learning rules, and the potential to manifest cascading effects. However, some certain drawbacks are associated with this approach, such as limitation imposed by the number of blocks in the model, uh, because challenges may arise when when dealing with the substantial quantity of services, as the network may need to output very small values, which is a like some float problem actually. So thank you for your attention. I'm ready to answer questions.
Thank you very much for your presentation. It was interesting, and I would like to ask that what your results of the results of your study, uh, what can suggest to for the policymakers. Actually, I would like to know that what are the implications for of your study for policy and planning.
Uh, well, actually, it's more like in well, actually, we can in policy and planning. I haven't actually thought about it. I mean, we thought about it in case of Russian master plan, or master plan as a whole strategic maybe document, uh, because uh, as today, I mean, in Russian practice, it may be well, actually, it may be another way to uh, assess the general plans or master plans in case of provision. So we can actually see how the local or or such bunch of local transformations will affect other areas of the city, and is it actually needed to do such transformation this way? I guess something like this.
Okay, thank you for your clarification. If anyone has any question, we can leave this article. Okay, thank you very much, Vasily.
Thank you.
And we are looking forward for the presentation of the next article, which is uh, entitled "Architectural Features of Museums Formation During the Different Centuries." And I would like to know if the presenter is online now or not. As we can see, uh, Anna and Vasily is right now online. Mm, so the last presenter is not presented here. And I would like to, we can finish this session. Thank you very much for everyone. Thank you very much for everyone presence, and I wish you have a good luck and in your future endeavors in conducting your research and academic career. Have a nice time and goodbye.
Thank
Thank
you.
you.
Goodbye.
Goodbye.